Adding and subtracting radicals. When we add and subtract radicals, the radicand, or the number under the radical sign, must be the same. So we have 3 square roots of 6 minus 2 square roots of 6. The radicand is the same, so we just subtract them. 3 square roots of 6 minus 2 square roots of 6 is just the square root of 6. All right, so number 2, we have the square root of 20 plus the square root of 45. So in order to add these, we must simplify and then add them. So go ahead and simplify and add them together. Try number 3. Number 4. Now we're going to divide radical expressions. And when we divide radical expressions, we can have them in 2 formats. We can have the radical real big and a fraction can be under it, or we can separate it using the quotient product property and have the square root of a divided by the square root of b. So this is the preferred method here. So here we have the square root of 25 divided by the square root of 9. And those are both perfect squares. The square root of 25 is 5, and the square root of 9 is 3, and 5/3 is simplified. All right, so let's simplify this one. So 3 square roots of 5, that can't be simplified. The square root of 9 can be simplified to 3. So 3 square roots of 5 divided by 3, the 3's cancel, and that leaves us with the square root of 5. All right, let's simplify this one. 5 square roots of 10, that's simplified. And 2 times the square root of 9, well, the square root of 9 is 3, so 6. So 5 square roots of 10 divided by 6. So there's one caveat when we are dividing by radicals. We must have a rational denominator. In other words, you cannot have a square root the denominator. So a square root is an irrational number. We can't have it in the denominator, so we need to change it so that there's no square root in the denominator. So before we begin, we need to review a few things. When we square a square root, in other words, when we take a square root times itself, it equals the radicand. So I have the square root of 2 times the square root of 2, really that equals the square root of 4, which is 2. So when I squared the roots, I got the radicand, the number under it. Square root of 3 times the square root of 3 is the square root of 9, or the square root of 3 times the square root of 3 is 3. The square root of 4 times the square root of 4 is 4. And the square root of 5 times the square root of 5 is 5. Square root of 6 times the square root of 6 is 6. See the pattern? So that means the square root of 2,305 times the square root of 2,305 is 2,305. So when we square or multiply a square root by itself, it equals the radicand or the number underneath it. So we need to keep that in mind. And the other thing we'll be doing is multiplying the expression by 1. So let's think about what that can look like. So if I have the fraction 2/3 and I multiply it by 1 over 1, I get 2/3. I could also multiply 2/3 by 2 over 2, which is multiplying it by 1, and I still get 2/3. I can multiply 2 over 3 times 3 over 3, which is still 1, and I still end up with 2/3. So, how about square roots? So here I have 2 divided by the square root of 3. So in order to get rid of this, when I rationalize the denominator, I can't have a square root. So whatever square root I have in the denominator, I'm going to take that and multiply itself by it. Because remember, the square root of 3 times the square root of 3 is going to be 3. So that's going to rationalize the denominator, get rid of the square root. And then I'm going to take that number, whatever it is, in this case the square root of 3, and just put it in the numerator. So in essence, I'm multiplying this by 1, and then I get 2 square roots of 3 over 3. Now that's considered simplified because there's no radical or square root in the denominator. And we can see that these are two equivalent amounts. 2 divided by the square root of 3 is the same as 2 times the square root of 3 over 3. The second form, though, is considered simplified, or the denominator is rationalized. So we're going to be doing that. So the first, to begin with, we're going to look and see if we can simplify this. So we have 5 times the square root of 25, which is 5 times 5, which is 25, over the square root of 15. Well, that can't be simplified. So now we have this simplified, and now we need to rationalize this denominator and get rid of the square root. So the way we're going to do that is we're going to multiply by 1. And what are we going to multiply? We're going to look in the denominator, and it has the square root of 15. So that's what I'm going to multiply by. That's what's going to go down here and in my numerator. So by doing this, I'm going to rationalize this, get rid of the square root. I'm not changing the value because I'm multiplying by 1. So now let's simplify. 25 times the square root of 15 is 25 square roots of 15. And remember, the square root of a number times itself is the radicand, so the square root of 15 times the square root of 15 is just 15. Now I have 25 times the square root of 15 over 15. Well, these both can be divided by 5. 5 goes into that 5 times, and 5 goes into that 3 times. So 5 square roots of 15 divided by 3 is my answer. Okay, number 9. 3 square roots of 3 divided by the square root of 2. So that's simplified and that's simplified. Now we need to rationalize. So we're going to go ahead and multiply by 1. We're going to go to the denominator, and I have a square root of 2. So that's what I'm going to multiply by, the square root of 2. I'm going to do it in the numerator and denominator. So I'm rationalizing, and I'm multiplying by 1. So now I have 3 times the square root of 6. And the square root of 2 times the square root of 2 is the radicand, which is 2. So go ahead and try number 10. Try number 11. Try number 12. Try number 13. Try number 14. Now we're going to solve radical equations. And when we do that, we're going to isolate the radical, similar to when we isolated the absolute value symbol. And after we've isolated the radical, we're going to square both sides. So here I have 9 equals the square root of x. So in order to get rid of the square root of x, I'm going to square the left and square the right. So that's 81 equals x. And remember, anything times itself, a square root times itself, is equal to the radicand. So when I square this, that's getting rid of the square root sign. Number 16, the square root of r minus 10 equals 2. So I'm going to square the left and square the right. When I have a square and a square root, they cancel each other out. They're inverses, so r minus 10 equals 4. So r equals 14. Try number 17. '18. 19. 20. 21. 22.